Right. Hello, everyone. Welcome. This is going to be a fun webinar. I'm Mike. I'm one of the co-founders of Tecton, and I'm our CEO. I'm going to share some slides in a second, but I just want to talk a little bit about what we're going to go through today. Personalization is an increasing topic again and again. And it's something that is going to unlock massive value. I was preparing something for our company earlier this year where I was doing some research on the economic forecasts for of the impact of AI. And it's expected that AI is going to add $13 trillion to global GDP by 2030. And $5 trillion of that is going to come from personalization. So personalization that's a huge impact, right? Trillion, that's with a T. That's a huge impact. But also, where's that $5 trillion going to come from? That's not an incremental thing, but that's a huge, if you're working any way in personalization, that's an opportunity to drive gigantic impact, but something's definitely changing in personalization to get there. And I think we're going to see a lot of new architectures arise, especially with the new stuff coming up with generative AI, RAG architectures. But it is our belief, there's been so much effort in the past on personalization with predictive AI that what we're really going to see is like a hybrid version of these. We're going to see both predictive AI and generative AI being used together to unlock a new type of personalization that's effectively going to be a step function. We're not going to get to that $5 trillion of impact through things like just getting better at adding better features to predictive models or using a simple RAG system, right? And so what we want to talk about today is a glimpse of that. This is something that some of our customers are doing. This is an augmentation of the standard RAG architecture that is a lot more personalized and can be used for a variety, many more use cases, and many more important use cases. And if you think of personalization and the value of it, what does it really mean, right? It means when our company, our product is making a decision, it's taking some impact, it's taking some decision that's affecting the customer experience, we're more likely to have the right experience for you individually, for that specific customer, right? And that goes across every part of the customer experience, from the sign-up flow to the checkout to I'm dealing with a troubleshooting, like with some support thing, even back office decisioning, like fraud detection. There can be personalized fraud detection that takes into account your personal circumstances, so they can have personalized risk levels, personalized pricing, stuff like that. This unlocks getting personalization deeply embedded in all of the different decisions that affect a customer journey. Can unlock compounding value. So all of these decisions can compound and unlock a really big amount of value. So I want to talk about how that can happen and walk through an example today. So again, I'm Mike. I'm one of the co-founders of Tecton, and I'm just going to walk us through an example today of let's imagine we were building an example company, which is trying to compete with a major travel company. So let me load up some slides and we'll show that off. Okay, cool. So, imagine we're trying to build like a booking.com competitor, right? We want to build a type of user experience where you just go to the homepage, the customer comes to the homepage and they get the perfect recommendation right off the bat, right? And how can we build this, right? This is way different than going into the web page and doing searching and comparing options and reading and doing a whole bunch of work as the user. This is kind of like the dream scenario where we just jump right to the answer for you and we have the perfect answer for you. So this is hugely valuable, obviously. And this is actually what every travel company would love to do. Every travel company would love to have this experience. So I want to talk about how can you get this experience? How could you build it, right? And how can you also like deploy it and all of that. So today we're going to talk about how this can happen, how you can build this, and then we're going to show some like of the actual practical challenges of implementing something like this. And we're also going to talk about how Tecton as a feature platform is a core component in enabling the kind of like augmentation on the RAG architecture that makes this personalization possible. So let's dive into it. First, let's just think of like a naive way to solve this, right? Let's ask ChatGPT, where should I go for my summer vacation? That's the question I have. ChatGPT, what's it going to say? It's going to say, go to Paris. It's going to say, give you the most popular thing, right? The most popular suggestion. Why is that? Well, what else could it do? It doesn't know you. It's just saying, this is probably the best, the most likely solution for everybody, right? And that is not likely to actually be a great solution for you. Maybe this is not the right place for you on summer vacation. So how can we get a better recommendation here? Should we fine tune a model? Well, kind of, but is it like really improving the model's intrinsic knowledge? No, it doesn't really teach the model more about you. This is not a bad option, but after we figure out how to personalize everything. Should we do prompt engineering? Well, we should always start with prompt engineering, always do some prompt engineering, but it's not fundamentally impacting the information that the model has about you. Should we do some RAG things? So should we retrieve context from an external system to augment the information that the model has so it can make a better decision? That's really interesting. We're improving the model's knowledge about the current situation, right? But there's a lot of nuance in how we do that. And there's a lot of ways we can implement this that just actually won't help at all. So let's dive into that. So what is traditional RAG? And I wrote Stone Age, kind of as a joke, but this is kind of like the bare bones RAG thing. So the question is, hey, where should I travel over my summer break? And so, what we will do in this standard architecture, we'll embed this, we'll issue it as a query into a vector database. The vector database is going to have some candidates. It's going to search over, a whole embedding space of different candidates. Imagine these are different like locations. So Paris, Tokyo, Johannesburg. And, it doesn't have a ton of context on these candidates. So it kind of seems like a weird embedding space for this type of use case, but it will issue, here's some candidates that we can pass back to a model. We can use an LLM for this, or we can even use like a normal recommendation system. And then it will choose one, but it'll choose, visit Paris. This is a low quality recommendation, right? You kind of don't see a lot of intelligence happening here. So it kind of feels like RAG is like a weird fit for this. But what do we want to have, right? So like what we're doing today is basically, it's kind of like with the RAG thing I just showed, it's kind of like we have a stranger travel agent. So we can build models that have high expertise, but they have low context. So that's why they're saying, hey, go to Paris. Like I know the best place. I know all this information about all these different places through my extensive common knowledge, but I don't know much about you or what you're interested in right now. So it's hard for me to tell you something, a suggestion that's better than this. What we really want is to have a travel agent who knows you like your best friend, who deeply knows you, who really understands what your preferences are, what your interests are, what your aspirations are, right? And this person would have high context on you and also have high expertise. And so that would be a response like, you said you loved that sailing trip last summer. Why not go check out the Rhodos Cup in Greece? Rhodos has a super cool old town with lots of great cafes, etc. Right? That's a lot more personalized. So without context, for example, in the traditional RAG, we just have these uncontextualized candidates. That's things like this, like Paris, Tokyo. There's not a lot of information for the model to use to sort between these. And so context is this very important information that models use to understand a situation, understand you, and use that information to make decisions, right? And so this term context is super, super important. So the context is what's enriching the candidate with more information to make it easier to reason about. So for example, this is the uncontextualized candidate we were just talking about. But if we were going to contextualize it first with more information about the city, so we can reason better about the city itself, we might add all of these different pieces of context, right? What's the weather there right now? Or at the time we're thinking of this trip, right? What activities do people do there? What is the nature like? Let's keep going down. What's the budget there? What language do people speak there? Is it easy to get a visa there? What's the nightlife like? These are all things we can make an endless list of this. These are kind of like intuitive things that you would want to know about if you're trying to figure out if you should recommend this place to a friend. This is still not enough, right? This gets us to, okay, we have an expert and updated understanding of the location, but we really want to match it to a person. So what we're looking for is personalized context. As personalized context enriches the candidates with user level information. So we talked about these two with like location context, but with personalized context, we're also able to know everything about the person, right, and their preferences. So what's their preferred climate? What are their interests? Are they interested in history? Yes. What's their budget? Luxury. What's their travel experience? Are they a seasoned traveler, or are they super, like, do they like going off the beaten path? We can think of a bunch of different things. You can think of the dimensions of your preferences that map to, that help influence where you would like to go for a trip, right? So this is like personalized context, personal context that we're appending here as well. So there's endless amounts of context. Let's talk about all these different kinds of context. There's information about the destination. So cultural significance, safety, what are the attractions, lodging and transportation, all of these things might matter. User-centric information, their travel patterns, demographic information, but there's so many other things. There's real-time information, what's going on there right now. What did the person just type into the website? Situational context. Where are they right now? Are they close to this place? Are they not close to this place? Do they want to go far away? Do they want to stay close? Is there any news? Is there any weather? Is there a hurricane there right now? We can just think of all these endless things that will help us identify and recommend the right thing. And the reason we're bringing this all up is because when you have higher context, you can get a much higher quality of response. So our goal in building the system is to get to the farthest to the right side. We're going to get all the way to the right side here. And by the way, I should mention that at the end of this, we're going to do a lot of Q&A. So if you got a question, add it to, I think Sergio's answering questions live, but also we'll do some Q&A live at the end as well. I just can't see your questions while I'm talking through this. So how do we do that? How do we do that? Well, we want to create personalized context by enriching candidates with relevant information. And so all of that personalized context is it's very similar to like signals about something, signals about an entity, about a user, about the location, stuff like that. And it's very related to this concept of features that we have in predictive ML. So we might start with an architecture like this, where we have a vector database that's generating some candidates. Hey, here's the cities that I'm interested in considering. And then we have a feature platform which is responsible for, like Tecton, which is responsible for sourcing other data and integrating it together to enrich these candidates. It looks like this. Let's connect to your various data sources, your candidate data, your user data, and then we can produce personalized, contextualized candidates that can go into a recommendation model. It can be an LLM or a traditional recommendation system. And that's how we get to, some really, really personalized recommendation. Kyoto is perfect for you because we can even, in this world, we can even explain why when we use an LLM. And so the feature platform is orchestrating. It's fundamentally responsible for assembling and creating and then delivering the context. So we can think of this as like a context management and context delivery platform, right? And again, the context is so critical for these models for these systems to output any useful recommendations. And so when we have higher personalization, we get way better recommendations. And so ideally, we just want so much of this signal to go into these systems, right? There's all kinds of things we can think about. And that allows us to go from an old world experience to something that's actually a really amazing experience. And nothing really exists like this today, right? So this is saying, hey, here's a recommendation for you. There's actually a last minute opening. There's a few coveted spots at Chef Takumi Nishimura's Sushi Mastery Workshop. And this is a few minutes walk away from you right now. And they're doing this thing, doing a class about some food that you've blogged about recently. And it's the weather's really nice, so you should walk there. And they're trying some alcohol that's something that you've mentioned that you're really interested in trying. So all of these things line up. This is like a completely impossible type of recommendation to build or experience to build even a few years ago, and it's becoming a lot more possible today. And we can even describe, why did we suggest this? Well, your profile celebrates this, and we noticed XYZ, and this is why we think this is a good fit for you. So how do we build something like this, though? How can we build amazing personalized context? So what I want to do is walk through these different layers. This is like the main part of this talk is, let's walk through these different levels of personalization. And we're going to get to the level where we can build the experience we just saw. So the first level is basically you have no context. This is one size fits all recommendations. This is kind of like what traditional RAG provides us. The candidates have no context from the vector database. They go into a model. The model can just tell you, this is what most people like. And that results in effectively a bad recommendation. So we're not interested in this, but this is just our baseline. And it's a really poor baseline. And so you wouldn't actually use this for this use case. You would use, obviously, like a normal recommendation system before you would replace it with like a traditional RAG system, right? But we can beat that. We can combine the best of both worlds. So that gets us to level 0. And that's, okay, so poor quality response. So next level 1, this is where we start introducing context from batch data sources. So we're trying to get personalized insights drawn from past behavior and profile data, right? So we're going to connect to we're going to augment this architecture to connect to a data warehouse, to connect to a data lake, and we're going to include talk to data sets that are about trips history, user interest, maybe user demographics, favorite activities, preferences, stuff like that. There's a lot of good information typically in our data lakes and our offline data sets, right? So we want to bring those together and join those and use this information to enrich the candidates such that we can pass contextualized candidates to a recommendation model at recommendation time, right? And that's often a pretty fast thing. Right? It happens in real time. So if we want to build something like this, there's a lot of things to do. We have to build pipelines to retrieve and to even transform, also to serve and join data from warehouses and data lakes, right? So it's a whole data pipeline, data engineering, productionization thing. But also we want to be able to evaluate these systems, right? We want to know, hey, how good of these recommendations are they? We want to generate a bunch of evaluation data points for recommendations that we were hoping to do in the past, that we would have made in the past. And so for that reason, we need to also be able to create historical evaluation data sets so we can benchmark and do development and compare different versions of what we're iterating on. And that's pretty tricky to do too. So we need to both have this productionized, but also, operate in a lot of data, big batch data sets, and compare them. So how can we do this? Well, I want to look at an example because solving these problems is exactly what Tecton is for. So Tecton is this feature platform. It's the leading feature platform for connecting to various types of data sources, and we'll go through quite a few types, and making and productionizing these data pipelines to be able to enable people to productionize high quality context, personalized context for AI applications. So we'll look at an example of how we can solve these problems very quickly with Tecton. So imagine we want to build batch context simply, right? So what are the last 5? Here's an example feature. What are the last 5 places this person has visited? This, I'm calling this a feature because it's an extracted piece of information that we would want to enrich the candidate with. So we want anybody to be able to write this stuff, to be able to iterate, define these signals, and productionize them. And we're going to look at how quick that is here with Tecton. So with Tecton, you just write in your Jupyter notebook, in your Python environment, you're just writing a couple of lines of Python code. And these lines of Python code are telling Tecton, which data source should I look at? The trips data source. What transformation do I want to do on that data? So in this case, it's a very simple feature. I'm selecting a handful of columns, and then I'm doing an aggregation on it. I'm saying the last 5 destinations, because this signal we're trying to generate is what are the last 5 places? This is the piece of context we want to deliver. The last 5 places someone has visited. And this is a signal that's about the user entity. So this is what last 5 places has this user been to, right? So we've got this little Python snippet. And so what do we do with it? Well, we can get historical data. We want to create an evaluation data set, right? So we want to enrich all of those candidates historically so we can then generate recommendations from them historically, generate 10,000 recommendations and see if they're good. And so we can backfill this signal through time, through the past year, 2 years, whatever we want, through one line, right? So we've created this object, use your last 5 trips destinations. And now we're just calling that object and saying, get features in range. And that's going to return a data set, a data frame that we can use to then generate recommendations with. So after we probably, our first version of this, we don't like it, and we want to iterate on it. Maybe we want to go, hey, the last 10 destinations. So we want to do some Python stuff to tweak this this destination a little bit more, to standardize it, do some pre-processing, some data cleanup, whatever. So we're going to iterate on this, and that's really important. This is all local, and we just iterate as quickly as possible. We can do this all in one cell in a Jupyter notebook. But then we get to a point where we go, hey, this is pretty good. Let's actually use this in production. So then we just have a one line to deploy to production. So it's called Tecton apply. When we run that, that's a CLI command, and we point it to the Python file that contains this definition. And what that does is it takes this definition, this signal definition, and it sends it up to the Tecton backend. And from the user's perspective, this signal is completely productionized and can be used in production immediately. So immediately we can start reading this signal for real recommendations at scale in real time. So now we can just, using the Tecton client, say, hey, get me all of the signals, and one of them in this feature list might be this feature, and it gets returned in 20 milliseconds. So it's really easy for someone who's a data scientist, an ML engineer, to do very fast local iteration, but also get their work into production to affect the production application, the production AI application, as quickly as possible, right? And we'll also talk about, you probably want to modify the end prompt that you're going to put into the model to take into account these new signals. So when we include this kind of information, this type of context, then we're basically including all of these types of data sets, and we can create a quality of recommendation that's like this. Visit the ancient city of Kyoto. It matches your interests, and we know you have extensive travel to historical sites, so you'll appreciate X, Y, and Z, right? So we know you've been to these kinds of places. Based on everything we know here, this is a good recommendation. So that's great, and that gets us much farther along. So much higher context, much higher quality of response, but we can do much better. So let's keep going. So level 2 is when we take into account streaming data, and then we begin making recommendations that adapt to someone's current interests and recent interaction behavior. So anything that happened pretty quickly in the past, maybe in the past 5 minutes, maybe in the past 2 hours, there's often a lot of session information that people are, activities that people are doing that do not map to, that do not land in a data lake or a data warehouse. And they tend to be very high quality signals that can help be very powerful context for a recommendation. So, so let's look at that. So that's equivalent to adding in, maybe these are Kafka streams, maybe this is Kinesis on AWS, PubSub in Google Cloud, but these event streams, this can even be in individual events we push into the platform that contain all kinds of different data about what someone just recently searched, what purchases just happened, what did they just click on the website? What video were they just watching on the website? All of these are data from recent sessions, something very recent. And that allows us to then enrich the candidates with streaming data if we have a feature platform like Tecton to allow us to integrate all of these together, right? And then we can get a much better personalized recommendation. So if we do this, this requires having streaming data. It requires connecting your application to Kafka, for example. But it's actually a pretty big challenge to operate on this data and integrate it into such a system such that we can build historical evaluation data sets and we can productionize it for real-time serving, right? And so if we're trying to do this, we have to start dealing with entering the world of building, evaluating, productionizing, and monitoring streaming data pipelines, right? And that's an engineering task. Now we're getting into the world where I need engineers to pay attention to this stuff, to help me productionize this stuff, maybe a team of engineers. It's slower to do this. It is kind of an embarrassment for the data engineering world that it's still so hard to do this. We have to make this simpler. The second thing is that these data pipelines tend to start getting into the realm of, hey, this is going to start costing the company real money to run this stuff. Depending on the scale and the configuration of these data pipelines, it's possible to configure the thing to meet the level of freshness that we need, start spending a lot of money and have costs run away. And we got to be careful about that. So there's a bunch of extra engineering problems that come into play, let alone how do you make this data available for an ML engineer or even a data scientist who's trying to work with this data offline. These are challenges. So one of the things that the Tecton feature platform is all about is making this as easy as possible. So we'll look at an example here about building and productionizing streaming context. In the past hour, here's the example. What topics did the user watch a video about? So it's basically the exact same thing. We're writing a stream feature view in a Python file. This could also be in a Jupyter notebook, just live. And we're taking into account the page events as a source. And we're filtering to video play events. And then we are outputting the video topics, right? So a row, a bunch of rows, and one of the columns is what's the topic of the video. And then we're doing so the features that we're outputting, one feature there's one feature and it is aggregating over all of those all of those events, video topic columns, and it's taking the last 5 distinct video topics. So this can give us a sense of like, hey, what's the user like looking at right now in the past 1 hour, right? And that's a really valuable signal. So basically here in this code, we've just defined this Python object. And then everything else is the same. How do I use this data to create a historical data set so I can do evaluations? Literally the exact same piece of code. And I can also combine this with the last feature we saw so they're all together. And we have consistent data sets. Then I productionize it with the same command. And then I can retrieve it in real time immediately as well, right? All of this is the exact same. It's the same workflow. So with this streaming, so that was really simple, right? It was just a couple lines of code, and we've built and productionized a streaming pipeline to enrich any AI application. enrich candidates for any AI application. And so now we can take into account locations viewed recently. Are there any pricing changes to be aware of? If there's a price just dropped, we can say, hey, heads up, there's an abnormally low price right now, right? There's this just went on sale, stuff like that. And that allows us to put together even better recommendations. Hey, considering you've recently been looking at trips to Japan and your recent interest is in fine dining, you should check out this place in this district in Kyoto, right? That's really cool. So that gets us even farther along. But there's a lot more we can do. And let's talk about the final level here, level 3. This is where we start integrating real-time context. So this is where we are building informed, personalized recommendations that use external events. So think of information that we're calling from external sources. We want to use the user's current context, and we want to use real-time inputs. So information that maybe the user inputs live. They say, I'm looking for these kinds of activities. Maybe we call out to external sources that have information about these events, or about these locations as well. So here's some examples. What is the query the user gave? What's their current location? What's the weather in those places, each of those places like? What's the traffic, flight info, travel costs right now? Anything going on in social media about them? We're getting to the point where if we can be really smart about integrating all these systems, we're getting to a very different level of personalization that's possible in our product experiences, right? And think about not just this cool, travel application, but this can apply to any level of product experience that you have in your application. And so this feature platform is now integrating across all of these different sources and is producing very high quality personalized context. But this is really hard, right? This is where we're getting to a world where now we also have to build and evaluate and productionize and monitor real-time data pipelines. This is information that's reading from the application in real time. We got to integrate third-party data sources. These are web sources. Maybe there's an API, a weather API we're calling, right? How do we productionize that? And who's going to do that? Is the person who's doing the offline analysis and the offline modeling going to figure this out? And then there's a huge and even more important trade-off between speed and cost. There's a lot of performance considerations. So we're getting to need a really big engineering team to actually build this kind of thing. Typically, it's a very challenging problem. And so this is another domain where Tecton tries to make this as easy as possible. So when we're building this real-time context, it works the same way. So here's an example. A really useful signal might be, how far is the user from the destination that we're considering, right? Well, we can write a little snippet of Python code the same way, in the same Python file even, where we take into account the device information, so the user's, whatever their phone location, their phone information, and the destination information. And then we're just going to extract out the location of both, so latitude, longitude of both. And then we're comparing them, and give me that distance in kilometers. We're also saying, hey, by the way, is this the same country? That's a really useful signal as well. And we're just outputting those two signals: distance to destination, same country. And we can even enrich this information with some metadata that describes what these signals are about, so the model knows how to interpret all of these signals downstream. But the point is, this is just a simple a few lines of Python, and then all of the steps about how do I backfill this to evaluate this signal and this signal's impact in a large set of recommendations. How do I productionize this signal? And how do I query this for the signal, retrieve the signal in real time? All of that's handled by the platform, right? And it's the exact same steps as before. I'll show one more example here. Imagine we want to know what's the weather like in that place right now, right? In that destination right now. Well, this one's a little bit more complicated because we need to set up an API source. We need to call out to some API. And so the API that we're talking about is the weather API, weatherapi.com, right? And so we're able to set up an object that's an API source. And then we're building the same kind of signal, weather features, right? Weather, and we're taking in the weather data API source, and we're extracting the current temperature and the current weather condition from both of these. And these can be any data format. They could be floats or strings or whatever. And so this is a float, current temperature is a float, and then the weather condition is some string. And now if we define those, we can run Tecton apply, and this is going to be a fully productionized signal. So these are things that would have been actually pretty substantial engineering projects to do. You can write this code in 5 minutes and have this be productionized in the same day. So it's all about how do you iterate as fast as possible offline and iterate as fast as possible to improve the production system. So that allows us to take into account user location, what events are happening there right now, local weather, flights, any pricing changes, stuff like that. And we can get to this really high quality recommendation. There's a last minute opening at a few coveted spots at Chef Takumi Nishimura's workshop. And it's a few minutes away from you. And it's a really nice night outside because we know the weather. And so we know it's actually a really nice experience to walk there. We know the path on the way. And they're doing a bunch of stuff that you've been very eager to try. So that's like a perfect match of all of the preferences you have and all of the existing opportunities, the various candidates of things you can do that someone could recommend. So it's a really great recommendation. And then we can also say, why did we suggest this? So I want to talk about one final level. And this final level is where we include, so it's real-time context. So it's level 3, plus we're adding feedback. So we can actually build now a user experience where we can allow the person to say, well, I'm looking for something that's more XYZ. Well, I'm looking for a more active thing to do tonight. And this is something actually we're supporting very soon in Tecton, building all of the data pipelines to make this super easy to productionize. But what happens is this involves recording context in feedback in real time and adding that to the context to the model such that the model can also reason about the context it just got from you. And then at the beginning of the talk, we talked about, hey, should we do fine tuning? Should we do prompt engineering? At this stage, once we've gotten this kind of architecture together, then we've really, we've maxed out the context. We've built really high quality context. It's got all the information that's needed to be able to provide a pretty personalized recommendation. And now it's not a bad time for us to do some fine tuning. So we've kind of like gotten really high quality data into the model. We've done a bunch of prompt engineering as well. And so if we do need to do fine tuning, which is not relevant for every application, but the fine tuning can really help us tune this kind of output to get the right kind of output that we want here. And when we talked about creating all those eval data sets, Tecton can also be really helpful for outputting, using all of these signals, the fine-tuning data set to make that model, to make it as easy as possible to build that model. Okay, so what did we learn? Just recapping here. Context is king. It doesn't matter what your use case is. If you're doing e-commerce, you want to have personalized experiences across every part of your website, right? From the item recommendations to the shopping cart, and to also like maybe even the fitting experience. If you're doing communication, you're building content, you're building marketing content, all kinds of personalization can unlock a ton of value here. Even in finance, right? Personalized financial advice. We have customers across almost every vertical figuring out ways to better personalize their systems, and they're using a mix. They're starting to use a mix of generative and predictive AI, and we think of this as kind of like a hybrid AI architecture. That's what we call full RAG here. So personalizing context can unlock amazing AI behaviors, and if you get better personalization, it's more valuable, but it's much harder to build. And we've walked through a bunch of challenges building this stuff. It typically takes, like right now, we see mostly only the most advanced tech companies are really building these types of architectures on their own because they're the only ones that have the engineering power to build this kind of stuff. But it's clearly able to unlock a ton of value. And feature platforms like Tecton are focused on helping people build and assemble and organize and deliver the highest quality, most personalized context such that any AI application can make the right decision and can upgrade the personalization and the fundamental quality of any AI application's output. So this is kind of what the finalized level 3 of the full RAG architecture is. We're bringing together candidates coming from a vector database, and we're enriching them with all kinds of data sources through a feature platform, which is managing that context assembly and context delivery for recommendations. And then we talked about also we can close the loop with a feedback loop, and we're going to do a follow-up webinar where we show that in detail. And then also the feature platform can output, once we're happy with that, we can also output the fine-tuning data set so we can improve this model as well. But it doesn't really stop there. If you're building this stuff, you've got a lot of other problems practically to deal with. How do you version this thing? How do you, it's not just one person building this thing, most likely. You're going to have to collaborate. How do two people work on the same thing together? How do you govern all of the data and ensure that you're using the data the way you intend? How do you debug it? How do you make sure it continues to run correctly? There's a lot of things here. These are all things that come out of the box with the Tecton platform. It just manages all of these kind of core enterprise platform capabilities. So you have a full-fledged platform to enable you to go as fast as possible and do it responsibly. And so you can try this today. So you can go to tecton.ai/explore. We have an interactive demo. You can build out this full DAG of all of the data sources and the context assembly that should be delivered to a recommendation model. And we're happy to help you. Also, if you're trying to figure this out, we'll hop on a call with you and show you some examples. And I just want to do one other call out here. You should check out Rift. So Rift is what we used in all of the examples today. It's the fastest path to real-time AI. So it's a Python native compute engine that is behind the scenes in Tecton that makes it really easy to do lightning fast development. You can build, you can test locally, you can productionize instantly. It supports batch, streaming, and real-time data and signals, and it's as fast as it gets. So this is a really important underlying engine that powers some of our most advanced customers and some of our least advanced customers who want the easiest way to productionize stuff. It's a very performant, and it's a really exciting thing that we've been launching the past couple of months. I suggest you check it out. You can you can just go and try it right now at tecton.ai/explore. Okay, let me stop sharing here. I'm going to check out the questions here, if there are questions. And Sergio, if you're on here, maybe you can answer here. Okay, I'm gonna open up some questions, and feel free to add more here. Here's one question: do you see personalization as a key feature of the smaller models like Phi 3? Seems like Apple will focus on ... although not with Phi X. Not sure I totally understand the question. So personalization is not really a feature of an individual model. It's more a feature of an AI system. And so we think a lot more about AI systems because those are the ultimate products that affect the customer, right? And so it's really important for us to get the right architecture, the right data into the models, garbage in, garbage out. Well, we want to solve that with our system. So if we can build the right context architecture, then we can make sure the model can make the right decisions. One thing that's interesting with respect to which products can be built with these types of architectures and how it relates to different models is that some models are a lot slower than other models. And this data assembly and all the context assembly and delivery, that whole information retrieval architecture actually tends to be a lot faster than LLM models. And so the smaller you get, so basically like the speed bottleneck tends to be the model itself. And so the smaller of a model you use, the smaller you'll be able to, the faster you'll be able to have your whole system, your end product experience working. Okay, I see a question. Is the RAG pulling all of this real-time data for every candidate location? And so the way this architecture shows it is we're actually doing that for the top candidates that we're interested in. So think of this as a multi-stage recommendation pipeline where first we're having a vector database or something else like that filter down to a short list. And then we're able to, for the short list, the 10, 20, 200, 2,000 even candidates, then we're going to pull all of the real-time information to enrich it. But you may have 2 million locations or candidates that you start from, and it may not make sense to do as high fidelity of a ranking on all of those. So there's one stage that is, hey, let's filter down to a relative short list, and then let's do a much higher fidelity ranking by pulling all kinds of extra signals to enrich that so we can have a high quality, a very high quality recommendation. Here's another question. How are we going to fetch the context historical data? Question mark, Snowflake. Well, so this is the core. This is a core data pattern that Tecton solves. How do you get the historical data? Well, in reality, people have their historical data organized in plenty of different ways, and sometimes they just don't have it organized at all. Frankly, sometimes it's something that needs to be generated. So there's kind of raw logs, but you need a lot of work to kind of reassemble the relevant signals. Sometimes there's actually already a data set of all of the historical data. Sometimes these historical signals have already been pre-computed. So it depends on how your data is all laid out. The good thing is that Tecton is all about flexibility and supports all kinds of different underlying data patterns that people have with respect to their historical data. And if that historical data does not exist, which is not uncommon, some people just, hey, we got to start doing this, but we've never stored things historically, so we can't even go back and infer like what these signals would have been. Well, then Tecton supports making it pretty straightforward for you to log these signals on an ongoing basis. We call this log and wait. So we can start creating these signals and creating a running log of them. That does require, hey, let's wait a little bit of time for us to generate a substantial enough data set for us to then act on with for us to evaluate or whatever it is. But that can be in Snowflake or whatever batch data source we're talking about. Okay, Mike asks, please explain the last mile for an application using level 3, specifically around eval, and how the tools are used, especially around testing the real-time components. Okay, good question. So there's a couple of types of testing you would want to do. So in eval, there's two parts, right? There's offline eval and then there's online eval. And so this actually is probably like a big enough topic for us to do a whole separate session on. But I'll do a quick overview of it. On offline eval, what you're really looking for is do my historical generation, do do the generations I have using all of this context. So this set of context parameters I've assembled, does all that context plus the right prompt plus this model, maybe it's a fine-tuned model, together output a high quality recommendation, right? And I want to do that. I want to evaluate that by looking at 1,000 data points or something like that, right? And so the way for us to be able to do that, we need to, as we were just talking about, assemble a lot of historical context, which is what Tecton handles. Assemble a bunch of like finalized prompts. So inject all of those contexts into the prompts that are going to say, hey, which thing should I recommend amongst all of these candidates, and then generate the output recommendation, the output inference, right? This is using a model in batch offline. There's an open question. It's, we don't have the answer at Tecton yet. And I think the industry doesn't really have the answer. Is, okay, so you generate, 1,000, 10,000 of these outputs, these recommendations. How do you tell if it's better or not? And there's a variety, depending on the use case, there's a variety of different ways that you can evaluate that. So that's the offline side. And of course, we can go into like, what are some of those ways? But I think you're more asking about on the online side. How do you evaluate, like, is this thing good? Is this what I'm looking for? And on the online side, there's a couple of things you want to ensure. You want to ensure, hey, does this operationally work, right? So you want to validate that all of the data, all of the context is being created appropriately. So it's kind of like the data integrity side of things. Secondly, you want to evaluate the kind of like engineering requirements, like the system integrity. Is everything arriving on time? Is the end recommendation being created and showing up on, all of the engineering things to show that it's showing up on the website properly, the right recommendation is being created. And then you want to have the right monitoring around this whole system to ensure that it continues to operate correctly, as well as validate that the data that you're creating in real time, the recommendations, the inputs to the model, all of those are consistent with what you evaluated offline when you made the decision to productionize this stuff. It's very similar to the same problem in predictive ML, right? Where we want to eliminate train serve skew. So we want to make sure all of the online data maps to the offline data. The online recommendations that are being generated in the exact same way offline. And so with the right monitoring, the right productionization of data pipelines, and the right operational monitoring. So data monitoring and operational monitoring, like checking on latency and alerting on all of those kinds of things, we're able to guarantee the system quality online. But there's also kind of product level monitoring you might want to do online, which is, ensuring that your click-through rate or your purchase rate or whatever the product level metric that you're defining is monitored as well. So it doesn't drop and it continues to hopefully improve over time. Okay, let me grab one more question here, and feel free to add any questions to the chat here. Really good question here. In fact, why couldn't I just throw everything into Gemini 1.5 Pro? Maybe the context window length might be enough. Super good question. I love that question. There's two things to consider. One, you could do that. Gemini 1.5 Pro, the problem is it doesn't know about your user, right? It doesn't know about like your personal preferences. So you still need to assemble the context to pass it into Gemini 1.5 Pro, right? So think of a model with a ton of context, like a very large context window. We can pass in a lot of information into it, but we still got to pass in that information. And so a lot of what we talked about today is how to assemble the right information easily to pass it into that model quickly and in a productionized way, such that we can actually build a product that is reliable, et cetera, using this data. But there's another consideration. And so like practically, why would you not use 1.5 Pro? The reason is that, one, with a super long context window. So I think you're saying like, imagine I didn't filter on candidates and I just had all 2 million locations. And then I enriched all of them with all of the location information, right? Couldn't Gemini, just figure it all out? And it's possible, but that model that's gonna involve a lot of compute, a lot of expensive compute. And so that's the reason why we do the pre-filtering on candidates, where we try to find like maybe the most relevant candidates, that whittle it down to 100 or 200. And then we can pass that into, then we can enrich those candidates and pass them into a model. And so when we talk about like, hey, it's a lot of compute, we're going to process that many input tokens. That means the model is going to use a lot of compute and be expensive, but also take a long time. It may take Gemini 1.5 like a lot of time, to maybe too slow for the product application you're trying to build. If you want to build a website that just opens up and boom, there's an amazing recommendation for you, Gemini 1.5 Pro may not be able to do that. Hopefully models get so efficient in the future that that's totally feasible. And then you don't have this candidate pre-filtering stage, and you can just focus on building as high quality context as possible, so you can have as much context passed into the context window as possible. I know we're using context in two different forms there, so that's a little bit confusing. Okay, that's great. Thanks so much for your attention, everybody. Again, we're happy to answer any questions about this stuff. We work on this kind of thing all the time with people, all different kinds of companies. Please get in touch and check out tecton.ai/explore. You can try this stuff today. Thank you.